24 out of 25. Let me explain what this topic is about. So I can think you'll get a guaranteed question, okay? So out of all the chapters that you have, you'll get one question from here for sure. Now, it's divided into four main parts, okay? Let me explain what they are. So first, you have, it's called medical physics, by the way, chapter name. It's divided into ultrasonography, X-rays, CT scan, and PET scan. Okay, so there are these four different types of processes out there. Good thing is that they can't ask anything out of syllabus because the questions are very standard. The bad thing is there's a lot of things to memorize. Okay, so you need to learn the working of four different equipment and the physics behind it. Okay, so if you are into let's say you're going to study medicine, right, or going to bioengineering or something, right, this is the only chapter you need from physics, okay, because this chapter is actually quite advanced. In fact, if you know a radiologist, you know who's a radiologist? People who work with X-rays, right? Ultrasonographer থাকে, the people who do ultrasonography, even they don't know this much. Okay? Because I've had students whose parents are like, radiologists, they didn't know the inner workings of it. So you're actually learning more than needed. And on top of that, you're going to also learn about the diagnosis process. Okay. So yeah, this chapter is quite comprehensive. It's our last hurdle. এখানে নোটস গুলো খুব ইম্পর্টেন্ট থাকবে, সো নোটস গুলো একটু ফোকাস করো. সো লেটস ট্রাই টু আন্ডারস্ট্যান্ড কি হচ্ছে এখানে. সো ফার্স্ট হচ্ছে ultrasound, and then we're going to do X-rays. দুইটা করে করব. হচ্ছে ultrasound and X-rays এর মধ্যে there are some similarities out there. I'm going to show you today. Right, so let's start with ultrasonography. Right, so what's ultrasonography and how do we use it for diagnosis purposes? So the main thing here is we're trying to use devices for diagnosis, not treatment. Okay, treatment and diagnosis are completely different things. Treatment is to actually cure the problem. Diagnosis is to figure out what the problem is, right? Now, before we start, we need to understand why are we using ultrasonography and how can ultrasound or sound help you diagnose. So the first thing you need to understand is we are using an idea that's quite old. It's basically the concept of echo. So the idea is, it can take originate for it. The idea is that when you have a ship and you want to find the depth of the ocean, right? There's this thing at the bottom of the ship. What does that do? It sends some waves out, pulses, right? And the pulses reflect and come back. So if you know the time taken for your pulse to go down, and if you know the time taken for your pulse to go back up, like that, you can use this information to find what? The distance and depth, right? So we thought, can this be done for a human body? Now, the reason why we went for this is because
recording in progress.
There was something else that's used very often. The first diagnosis tool ever made, right, is actually the X-ray. So X-rays predates this by 50-60 years. X-rays are from 1910. So X-rays are problem ki chilo. X-rays, as the name kind of suggests, and you know about it, it has this negative impact on the body. It's ionizing, right? And it can cause harm. So আমাদের যে X-ray, we still have X-ray in our syllabus, by the way, okay? But we wanted to use something that's more, safe to the human body. Turns out, sound does nothing to the human body. The sound doesn't have ionizing ability. Sound doesn't have any kind of harmful effect. It's not even detected by the body because the sound we are using here is referred as ultrasound. And do you guys know what the frequency of ultrasound is? Right, ultrasound is any sound that has a frequency of greater than 20,000 hertz or 20 kilohertz. So if you actually beam ultrasound into your body, you wouldn't even notice it because our body can't hear ultrasound, right? So yeah, you're sending ultrasound into the body, and ওইটা use করে will do diagnosis. So it comes all from here, এই idea, the concept of echo. But we stumbled upon a very big problem. So আমাদের এখানে just মনে রাখতে হবে, we're not learning the process of ultrasonography, we're also learning the equipment. And equipment
recording stopped.
Physics is quite complicated in your the devices. Okay, so let's first start with the components of ultrasonography. So the first component that we have is called transducer. So what's a transducer? Transducer is not for ultrasonography. It's basically an electrical device. It's a device that can do two things. It can receive signals, and at the same time, what can it do as well? Transmit. And this is very important for our ultrasonography. I'll show you in a minute. So any device that can receive and transmit is called a transducer. Now, we are going to solve three problems here. Number one, we need a device that can both receive and send signals at the same time. Not literally at the same time, but it can do the same thing. Number two, it must be a device that can produce what frequency? 20,000 plus, oরকম frequency দরকার, right? So because I can do this. That's like, 10 hertz, right? But I need 20,000 hertz. 20,000 hertz is not a joke. 20,000 hertz money, your object is going to vibrate back and forth. How many times every second? 20,000 times, right? That's mechanical limitation. Some materials won't even move. Like, I mean, if a pen can vibrate for 20,000 hertz, right? You wouldn't see it happen. Because it's so fast, before the pen can move up, right? It needs to move down and back up and down multiple times within that time frame. The object is like stuck there. So we need something that's capable of doing what? Very frequent oscillation. So that's one challenge we had, right? We had to get into what range? Ultrasound range. Secondly, we needed some device that can what? Receive and transmit. And lastly, we wanted this thing to visualize the information. Not only capture the information, also show it to you. And this is actually a limitation. We'll see later on. Most of the high-end medical equipment came in the last 20 years because you need very advanced computing power. Okay, so back in the 60s and 70s, ultrasonography machine they were very primitive. The output was very limited. It's it's almost real-time what's happening. I know you have probably seen an ultrasonography. They'll hold something on your body and then they'll see what's inside, right? 30-40 years back, clear it was much hazy. It's much more real time. Measurements now, you can find the size of things, compare the size of things, pause. So all of those are possible because of what? Computing power. And I think you know that the computers that were used for moon landing, right, is actually less powerful than the chip in this calculator. And we went to the moon with a computer that has less processing frequency than this calculator's chip out here. So you can understand the limitations out there, limitations of Sonicom. Anyways, so how do we come up with this device, the transducer? So a transducer, we came across this crystal. It's a fascinating crystal. I think this is the future of humanity. At the moment, it's not very easily, readily available, but the things it can do, right, is almost magical. I'll tell you people later. So this crystal is called the piezoelectric crystal. Piezoelectric crystal. So what is this piezoelectric crystal that we have? So this crystal has some very unique property. And there are different types of piezoelectric crystal. The one we'll be working with is something you have heard, quartz. So quartz chemical formula ki tumra jano? What's the chemical composition of quartz? Okay, it's just like if you look into it, right, it looks like an address, like 20-digit hectogen. It's like oxygen, nitrogen, sulfur, phosphorus. There's a bit of silver, and there are different molecular structure within it, all combined to form this thing called quartz crystal. Why is quartz so famous? So quartz typically kothay use kora hoy, do you know? Yeah, it's used in watches. Okay, very expensive watches, they use quartz crystal in them. Do you know why? Quartz, right? I know some watches randomly quartz lekha na niche. That's the karon chhara. I mean, why does it have a quartz there? Yeah, it's working on a battery. So quartz crystal there are these crystals, right? And the crystal gulo nije theke oscillate kore. They keep oscillating on their own. And the thing about quartz crystal is that the size of the crystal controls the frequency of vibration. So if you take a quartz crystal, right, and you cut it to a particular size, what the frequency control korte parba. Different sizes have different frequencies out there. So if you want a quartz crystal in your watch, right, what would you do? What's the frequency of oscillation in a watch? 1 hertz. Every second, one, right? So you take a quartz crystal, and then what you do is just a second.
Recording in progress.
Yeah, so you take a quartz crystal and then you size it up. And if you can size it up properly, you can control the frequency at which it oscillates. But that's not what we want. The quartz crystal purpose is completely different. What we're going to do right now is take a very thin layer of this crystal. Okay, এরকম একটা layer নিব। এই layer ভিতরে there are multiple stacked layers on top of it. Like crystals go okay, এভাবে stack করা হয়। Think of like layers of glass placed on top of each other. Okay, so that's your quartz crystal that you see here. And we found this very interesting phenomena. If you take a crystal like this and you place two terminals across it, like metal, and you apply a potential difference across it, like a voltage, something interesting happens. So when you apply voltage across the quartz crystal, the crystal changes its shape. So I'm using like a battery নেই, and I provide a voltage across this quartz crystal, right? কি করবে? এটা shrink করবে. It becomes smaller in size. The voltage can control the spacing between the layers. So এটা কেমনে কাজ করে একটু বলি। What's voltage at the end of the day? Potential difference. What is that at the end of the day? Polarity, plus and minus. So when you put plus and minus, the crystal realigns itself. And কি হয়, এটা ধরো loose থাকে, it tightens itself up. তাহলে কি আরো compact হয়ে যায় না? তুমি voltage দাও, let's say you put in plus and minus from both sides and you're applying field across it. Wouldn't the particles that are randomly just astray or line up with each other? And when they line up, the way the crystal works is that everything compacts and becomes very tight. So এখানে যেটা notice করা যায় is that the size changes. So you'll notice that এটা size change করে. Now the thing is, size-টা হচ্ছে এখানে decrease হচ্ছে. It's becoming compressed when you provide a voltage here and potential difference. So let's say potential difference এভাবে provide করলাম, এটা plus, এটা minus. But the interesting observation was, if you reverse the potential, মানে তুমি potentialটাকে যে উল্টা করে দাও, right? Let's say this is this and that is that, right? What will it do? Yeah, it'll actually expand. It'll go the other way. So এটা কি করবে? অন্য সাইডে চলে যাবে. So what we found was that by applying potential difference across this crystal, you can change the watt of the crystal, the shape of the crystal. So I mean, at the example, this is my crystal here. This is 0 voltage, positive voltage, 0 voltage, negative voltage. So, you can use voltage to manipulate the watt of the crystal shape. Okay, so that's what we saw. But why is that important for us? So we figured out that quartz molecular level mechanical structure নাই কোনো রকম, মানে it's very fluid. It can vibrate as much as you want. So what we decided to do was, instead of providing a DC supply, we provided a watt supply across it. Yes, we provided an alternating supply here with a frequency of how much? 20,000 hertz. And the moment you provide a frequency of 20,000 hertz here using like an external power source, this crystal that you see here, what does it start to do? Just do that. How many times every second? 20 times every second. And it's a mechanical limit now, because these are molecules. Molecules of frequency can go up to 1,000,000 hertz. So 20,000 is nothing for it, right? So by doing that, you can make the crystal go back and forth like that. And as the crystal oscillates back and forth like that 20,000 times, what around it oscillates at that frequency? The air, the fluid, the liquid, the muscle, the tissue, whatever it is, right? And it starts to generate what out of it? Sound, because the vibrations are to and fro, back and forth, and the wave is traveling that way. So you have a series of what set up here? Compressions and rarefactions. So when this thing, AJ, when you have this thing here, when it expands, you have a compression. When it contracts, you have a rarefaction. Okay, so basically a series of compressions and rarefactions is set up, and this is how we generate what frequency in the body? 20,000 hertz. So I'll show you the process. So there's this thing, if you ever do an ultrasonography, you'll find that they have this device. That's the transducer. At the probe they put it on your body, right? At the top end, it's a crystal. It's a very fine layer of crystal out there. They connect it to a power supply. The power supply has a 20,000 hertz. And as it provides that vibration to the crystal sends the vibration through your body. And that's how the wave is generated. That's how we create what? Ultrasound. But remember, our first scenario was not to create it. To what and what? Yeah, to send and receive. So now we have learned that there's a possibility of transmitting it. But how do you receive the signal back? So what will happen is, the signals will travel through the body, and they go through the body, and they bounce off a surface, and they come back. What can detect them? So surprisingly, the piezoelectric crystal, I told you, it works like magic, can do that as well. How is that so? We found that when you compress the crystal on your own, তুমি হাত দিয়ে যদি চাপা দাও, it generates a voltage. তুমি যদি ওটাকে হাত দিয়ে টান দাও, it also generates a voltage. So basically the crystal works like this, okay? See what's happening? You have your crystal, right? You provide a voltage, it goes in. Are you with me so far? Achha, you have the crystal, you push it in. What does it do? Create a voltage. It works both ways. So তুমি যদি চাপ দাও, it gives you a voltage. তুমি voltage দাও, নিজে থেকে নেমে যায়. So when you have this crystal here doing nothing and a wave shows up, isn't a wave a series of compressions and rarefactions? As the wave shows up, it pushes this thing inwards, right? If you have like a voltmeter attached across it, what will it read? A voltage. And the voltage is directly proportional to the amount of what it undergoes, the compression it undergoes. So you can think of voltage to dekhe, you can actually figure out not only the wave coming back, but the what of the wave coming back, the intensity of the wave coming back. Are you with me so far? So I'm using 5 volts a day and it compresses 5 centimeters. I compress it 5 centimeters. How much voltage does it give me? 5 volts. Okay. So the thing is that as this thing, the wave shows up here, it compresses and relaxes. So যখন relax হবে, তখন কি হবে? Any prediction? মানে আমার normal size এটা compress হলে I get 5 volt, right? What if it's stretched out? What happens then? You still get 5 volts, but a negative 5 volts. Okay, because remember, positive hole compress hoy, negative hole ki hobe, relax hobe. So yeah, this is the reason why I'm on the future of humanity is piezoelectric crystal. The only reason we are not using it right now is because it's very fragile. The crystals are very thin, they break very easily. But what are its implications? Where can you use them? So imagine the room here, the floor is made up of this crystal, right? Every time you walk over it, right, what do you generate? Electricity, right? And then you can have a carpet, you can have, in fact, they had this prototype of this I think this random a t-shirt that has a very big piezoelectric crystal in front of it. কোথায় t-shirt use করা হয়? In concerts. So তুমি concert ওই t-shirt পরে যাবা, right? It has a crystal in front of it, very loud blaring noise and sound. ওইটা তোমার shirt কে vibrate করবে and it charges your phone. Okay, so you're basically charging your phone through the music in the concert. You get my point? So yeah, that's like they did something like that. The part slow where the crystal, as you walk by, loudness, your shirt glows, light diluted. I said that these are like the stuff they could do so far. But the thing is that the application, I think Finland but Norway is that roader mode speed breaker speed breaker in niche they place these crystals. Okay, so advantage to keep. As your car goes over them, right, it pushes it down and it produces electricity. What's the use of that, right? So they're in carbon neutral country, but they don't use any carbon dioxide production, right? So they have a lamp in the front. So every time the car goes over this, right, ওই এনার্জিটা থেকে ল্যাম্পটা হচ্ছে গ্লো করে ওঠে. So you're basically lighting the road with your own energy as you drive by. But 1 meter square of it is $30 million. So 1 meter square is like a TV show on size যদি চাও একটা, it'll be close to $30 million and it's very fragile. So যেটা ফিনল্যান্ডে করতেছে ওরা they're using like a prototype of artificially lab grown quartz. ওইটা দিয়ে করতেছে. Its outcome is its efficiency is not that good. Okay, if you get the actual quartz out there are other piezoelectric crystals, by the way. All of them have these properties, but the main idea হচ্ছে you press them, they produce electricity. You give them electricity, they change and mold their shape. So they can change their structure and whatnot. So এটা use করে we create what is known as a transducer. Okay, now ships use kora hoy, but ships crystal use kore na. They use a different version out there. Just bole rakhom because shipper gulo khub cheap thake, but they lack what? Precision. These are very precise because they're very small. They can pick up very small vibrations. They can pick up very small changes in vibration. যেটা শিপে দরকার নাই তো শিপে you want big changes, right? So yeah, this is called the piezoelectric crystal. এটা use করে what we do is we design our transducers. So যখন ultrasonography করা হয়, the person doing the ultrasonography, performing the ultrasonography, দেখবে এরকম একটা টিউবের মতন থাকে হাতে নিয়ে ওটাকে মুভ করে over your body, right? That's the transducer. And inside this there is a crystal. ওই ক্রিস্টালটা হচ্ছে vibrate করে. Now here comes the important part. The piezoelectric crystal can't send and receive at the same time. It can send or receive. Do you understand why? Because when it's sending, isn't there a voltage across it? When it's receiving, right, there is a voltage generated by it. If you do both simultaneously, right, what will happen? They'll contradict each other because it's a voltage you're providing and it's a voltage it's providing. So দুইটা কি উল্টা দিকে যাবে না, so it cancels out. That's the reason why while doing ultrasonography, right, we do not send a wave. What do we send? A pulse. Pulse হচ্ছে a short burst. So আমরা কি করি, আমরা একটা short burst of ultrasound send করি. এই ultrasound burst goes through the body and comes back, and after it comes back তারপর আমরা second send করি. So we do like burst, it goes, comes back, receive হয়ে গেল, then the burst goes, comes back. So এটাকে বলা হয় pulse interval. What's pulse interval? একটা pulse থেকে আরেকটা pulseর গ্যাপটা. So why is pulse interval very important? So imagine I send my pulse out, right? Pulse যাচ্ছে, bounce করলো, it's on its way back. I send out another pulse. Wouldn't that be a confusion? Because now I don't know which pulse is what. দুইটা pulse পাঠালাম, দুইটা on their way. কোনটা আগে কোনটা পরে, I wouldn't know. So the rule is whenever you send a pulse, you have to wait for it to what? Completely come back, and then you send the other pulse. So a interval between pulses is called the pulse interval. You get my point? আবার অনেক সময় pulse interval তোমার ঠিক আছে, but তোমার pulse duration অনেক বড়, মানে the pulse is gonna stay on for too long. ওইটার problem. কেন? You're sending the pulse, right? Pulse যাচ্ছে এখনো, reflection only চলে আসছে. Wouldn't that be a problem? মানে তোমরা কি pulse interval আর duration এর difference বুঝতে পারছো? Intervalটা হচ্ছে এটা. Okay, let me try to help play and show you. The what about between two pulses? Time gap between two pulses. So pulse are pulse length and pulse interval টা বুঝায়, okay? So এমনি ক্রিস্টালটা দেখতে এরকম কিছু না, র্যান্ডম রক একটা, বাট yeah, it's quite interesting. দেখো voltage দিলে, of course there's a major chemistry behind this, যেটা আমি লাগতেছে না, but you can see the structure here. With a 10 volt দেওয়ার পর দেখছো the thing expands itself, right? So that's like when voltage provide করা হয়, it expand করে, আবার voltage provide করলে it can contract itself if you provide the voltage which way? The other direction, right? So এরকম করে ক্রিস্টাল গুলো নিয়ে এগুলা randomly form হয়, and এখান থেকে you need to use laser to cut them into thin slices, and slice এর মধ্যে কোনো imperfection থাকতে পারবে না, like there can't be a fracture or anything, তাহলে কাজ করবে না. That's why it's so expensive. Okay, এই ক্রিস্টাল গুলো অত এক্সপেন্সিভ না, ওয়াচেস এ ইউজ করা হতো, এখন অনেক জায়গায় ইউজ করে, but when you want to use it in a transducer, it has to be very refined. কেন করে? আচ্ছা, সো এখন তো আমরা ওয়াচে হচ্ছে কি ইউজ করি, ব্যাটারিজ, রাইট? 100 years back ব্যাটারিজ তো ছিল না, বাট ওয়াচেস আর 500 year old, মানে 500 years আগে থেকে ওয়াচেস ছিল. সো হাউ ডু দি ওয়াচেস মেনটেন 1 second oscillation? সো দে ইউজ টু ইউজ দ্য ক্রিস্টাল ইনসাইড. ক্রিস্টালটা এরকম করে কাঁপতো, the vibration, ওই ভাইব্রেশনটা ইউজ করে they used to time the watch. ভাইব্রেশনটা সেট করার জন্য you need to give it energy. তার জন্য there are some watches called mechanical watches, battery থাকে না, তুমি just handshake করবে ব্যবহার করে, and it'll run for like 2-3 days. It uses your motion to create the oscillation. ওইখানে এটা ইউজ করা হয়. Usually very expensive watches, and the higher the cost, the more refined the seconds are. So অনেক সময় দেখা যায় যে you have a quartz crystal in your watch, every day 5 minutes slow হয়ে যাচ্ছে, তার মানে it's not tuned properly. The really ones, which ones basically একদম মানে 100 years ধরে চলো মেইনটেইন করতে পারবে if you take good care of it. Okay, কোনটা? No, so to produce sound is a new thing, but the vibration, the frequency, the oscillation, this is a very old fact. কোনটা? The transducer না, সে তো হসপিটাল ইউজ করে সবচেয়ে না ওই আল্ট্রাসোনোগ্রাফি মেশিনের মধ্যে they use like 1 millimeter একটা piece. So it's not very big. ওই 1 millimeter দিয়ে হচ্ছে কাজ করে ওরা. So that's why $30 million এর যে সাইজটা, ওটাতে you can probably build, I don't know, 300,000 ultrasonography machines. Okay, try to understand pulse duration and pulse interval. Okay, এই যে কথা না. So what's pulse duration? It's this. You know how long the sound was? Or I'll make a short duration. That's a short duration, right? Our pulse interval হচ্ছে You see the gap between them? That's pulse interval. So what if my pulse duration is this? Sound যাচ্ছে, but our ফেরত চলে আসতে start করছে. Wouldn't that be a problem? Because my device is now in what mode? Transmission mode, but it's supposed to receive as well. So we need to what the pulse length, reduce it so that এরকম কিছু একটা হয়. গেল, ফেরত আসলো. Then I send the next one. আবার ফেরত আসলো. So that's like a good interval. Why? You're allowing time for the signal to come back before you send the other one out. So there are two things you have to be aware of. একটা হচ্ছে pulse length, মানে ওইটা এটা, how long it lasts. আর একটা হচ্ছে pulse interval, ওইটা হচ্ছে the gap between them. এই গ্যাপটা, that's pulse interval. Okay, so yeah, এটা নিয়ে কোনো question ওরকম করে না, but you need to be aware of the fact that when you are using it, you have to set the system into that particular frequency. So yeah, that's your transducer. কোনো question থাকলে আমাকে বলতে পারো. Do you have anything that you want me to clarify? So এখানে notes গুলো দেওয়া আছে, I'll go through it কি দেওয়া. So first হচ্ছে this is the crystal, okay? Piezoelectric crystal. It's basically quartz. So তোমাদের example চাই না, but you'll find in your mark scheme quartz mention করা থাকে. And what you do is you provide a positive voltage here, +10. Do you see the amount of stress it experienced, right? কি হলো এখানে compress হয়ে গেল. Now if I provide -10, same amount of force exert করা হবে, but which way? The other way. So if you give a positive voltage, it compresses. If you provide a negative voltage, it relaxes. So by giving plus minus plus minus plus minus, you can make it do what? Like that. And as it keeps doing that, it can generate what using it? Sound. That's how sound is generated. Remember the microphone, sorry, loudspeaker in your O levels with the magnet, right? So base same thing, right? But the other thing that makes it very interesting is that আচ্ছা উল্টাটা বলছি মনে হয়, এই যে এখানে +10 দিলে it compresses আর -10 দিলে it relaxes, আর তুমি যদি নিজে থেকে compress করো, what will it do? Give you a plus voltage, আর নিজে থেকে যদি relax করো কি দিবে? একটা minus voltage. Do you get my point? So yeah, that's how it works. এখন হচ্ছে how does this help you get like a image of the body? মানে ভিতরে কি হচ্ছে ওটা কেমনে পাওয়া যাচ্ছে? So এটা আমি একটু দেখাচ্ছি না minute. Positive voltage. Why is it that way? Voltage দিলে হচ্ছে you have positive field generated across the ions. So a positive field এর জন্য হচ্ছে the ions try to move towards the positive terminal, so they stretch out. Negative দিলে you are pushing them away, so they move towards each other and they compress. Why doesn't it suddenly? Oh no, so a crystal, that's the thing about piezoelectric crystal. Piezo properties বলা হয়. Piezo properties are crystals that have elasticity in them. Or elasticity change based on potential difference across them. With let's say salt এটা কেন হয় না? It's very rigid. Salt's structure is very strong. So when you provide voltage, the bonds can't change because it's very well structured. A crystal, the bonds are a little fluid, they can move around. So by applying voltage, you can change their shape. Yeah. Why doesn't this happen with water? Water hoy, but water molecules just move that way. That's like, what happens with electrolytes. So let's say you put two terminals in a liquid water that has salts dissolved in it, right? What happens to the ions? Yeah, the negative goes to the plus goes to the minus, but the shape of the water doesn't change because the particles can flow within it. A crystal, the problem is it's a solid, right? So what happens is the particles start to move, literally taking the structure with them. So it expands, the size increases. Okay, let's just go through this. What's a piezoelectric crystal? These crystals are made of structures that generate potential difference when a force is applied across it. And they also generate a force when a potential difference is placed across them. You get the two-way version here. So when you apply a potential difference across them, what does it generate? Force, right? And when you provide a force across them, what does it generate? Potential difference. Power supply. So you take a power supply, alternating power supply, or a power, like a power supply that you can control. You connect it across the crystal, and then in that you set what kind of supply you want. Do you want a DC, AC, 10 volts, 20 volts, and that will continuously be provided across it. Oh, right. So what happens is it's very similar to Hall probe. Remember Hall probe, where the electrons move one side? So you have this crystal here, there's some stray electrons within it. When you press it, right, the electrons move out from the structure. And as they move out from the structure, they create like one layer of electrons there, and it's devoid of electrons out there. So that creates the potential difference. And if you pull it out like that, the electron goes the other way. So that's the potential difference changes its polarity. So that's how it's done. The analogy I found online is like a sponge. So you have a sponge with water in it, right? As you press it, what happens? The water comes out. But if you put water in it, what does it do? It expands. So the water is like the thing that's moving around. Here it's in the electrons. Okay. Right. So what's a transducer? Transducer জিনিসটা কি? So transducer consists of a crystal connected to a high frequency alternating supply. The crystal is also connected to a computer to receive any voltage generated across it. I'm going to show you what the computer does. Computer কাজটা কেন important here. When a high frequency voltage is generated across a crystal, it oscillates at the same frequency, generating vibrations in the form of longitudinal waves that travel through the body. মানে আমার যে crystal across আমি হচ্ছে একটা AC supply day with 1000 hertz. The crystal will go back and forth how many times every second? 1000 times every second. It'll produce a sound or vibrations of what frequency as well? 1000. So তোমার voltage frequency is the sound frequency. Using voltage to the sound to create cortisol, right? And these waves then reflect and return, making the crystal vibrate, and this process generates potential difference across this. This PD can be analyzed by a computer to show the structures inside the body. Eta kemne hoy full detail jante hobe, including math. There's a lot of math here, by the way, okay? So oita amra ekটু pore jacchi. We just started with how we work with it. So are you clear so far? Kemne kaj kore? Right, so if you have any questions, let me know. Right. So let's see how your ultrasonography actually works. How does a doctor, right, who's performing an operation or trying to figure out what's wrong with you, a ultrasonography they figure out what's going on there, right? So let's see. So a part of the working the mechanism of ultrasonography. Listen carefully, okay? This one is an 8-mark question. So whatever I'm going to say right now, পুরোটা word লিখতে হবে for 8 marks. So প্রথম থেকে carefully শুনো. So the question would be, how is ultrasonography done and how is the ultrasonography image obtained? The whole thing, right? So look at this. Screen একটু দেখো কেমনে কাজ করে. So this is the body, and bodyর মধ্যে হচ্ছে we're going to put different structures here. So this is the outermost layer, which is your skin. তারপরে you have a layer of fat. Then there is muscle, there is tissue, and there's bone. Okay, so these are different layers out there. Ultrasonography main objective is to find what? Differences in boundaries. Let me explain what does it mean. Do you guys have ultrasonography in like biology or anything? No? No? Do you have MRI? এগুলো বাদ দিয়েছে আগে ছিল? Yeah, so Excel আছে, but ওদের আবার physics এটা নাই, so that's why it's a little different. I don't know. Either way, কেউ পারে না. So right, so these are different boundaries out there. So how does the ultrasonography work? So look at the process. You take your transducer, right, and you place it on the body. And then what the transducer does is it sends a pulse inside the body. So body take a pulse send for one single pulse. And that pulse, keep it to that. This is very important. Listen carefully, okay? The pulse will enter your body and it will undergo reflection at every boundary. Listen to that, okay? Reflection at every boundary. What does that mean? Say sound taking the gallo. Jawar pore, it hits a boundary here. So what's a boundary? A boundary is a place where the medium changes. So muscle to tissue, tissue to muscle, bone to something. Whenever you have a change in structure, it's called a boundary. And whenever sound hits the boundary, it always what? Reflects. Now, it's not a sound thing. It's a wave thing. Wave will always reflect from where? A boundary. You have seen this in your O-levels. If you remember, আমরা যখন পানি নিচ থেকে একটা wave send করতাম to the outside, remember total internal reflection? But I think you'll also remember that there's always a what happening. partial reflection. So whenever you provide a boundary, there's a partial reflection. An example would be like window. You have a very transparent window out there, like fully clear, but you'll stand in front of it. You can see outside clearly. You can also see partly your what? Reflection. So reflection always takes place. So you can reflect করে ওয়েভটা ফেরত আসলো। But then যে ওয়েভটা ট্রাভেল করতেছে, do you think it's the same intensity or little weakened? Weakened, right? So একটু weakened এখানে আসলো। তারপর আবার কি করবে এটা এখানে এই বাউন্ডারিতে রিফ্লেক্ট করবে। So it reflects and goes up like that. এইসব বাউন্ডারিতেও কি হয়? Slightly reflection. And then it goes there, again reflects and comes out like that. And then it goes there. And by that time, our ফেরত আসতে পারে না because it's all like, dies out very rapidly. So every time it meets a boundary, what does it do? Reflect. And এই reflections গুলো যখন back করে, do they all come back at the same time or there's a delay between them? Yes. By knowing how much time they took to go and come back, the computer can process and tell you where they are. And that's how you find a location, right? Now, একটা thing হচ্ছে, how would a doctor know it's from a muscle, tissue, bone, or muscle? Because muscles of different type, right? So it turns out, and this is a bit of biology out there, can you tell me what's the difference in the structure of a muscle and a tissue? Muscles are more, right? And tissues? Single cell, everything is single. So what's single? It's a microbe. That's a single cell organism. Random. Okay. But in terms of chemical composition, right? If you look at the muscle and the tissue, right? What's different or same about them? Muscle has? Exactly. Okay. So do you know what the composition of a protein is? The elements? No, the elements. Okay, so carbon, hydrogen, oxygen, nitrogen, sulfur, a bit of phosphorus, phosphates. So these are the elements that you have where? In your muscles. Tissues also have the same thing. So muscles and tissues there, differentiation ta ato easy na. So when a reflection takes place between a muscle and a tissue, the reflection is not very strong. So the idea is that the reflection is very prominent if the two material and boundaries are what? Very different. If they're very similar, the reflection is weak. Don't you follow what I'm trying to say? So if you go from muscle to muscle, reflection because they're what? The same material. But if you go from muscle to tissue, you might get a small amount of reflection because the muscles and the tissues are slightly different density. But then if you go from a muscle or tissue to a bone, what will you get? The highest amount of reflection. The bone almost literally completely blocks the sound because it's very dense, right? So boner থেকে যে reflectionটা back করবে is supposed to be the what intensity? Highest intensity. So এই informationটা যখন back করে, কেমনে back করে? So there are two ways the information comes back. একটাকে বলা হয় the amplitude scan, A scan. So A scanটা কি একটু explain করি. And this is important to screen এ দেখো কি দেখাবো এখন তোমাদেরকে. So I sent out a pulse. This is the pulse I sent, right? The sound that I originally had. A pulse is a part is the what of the pulse? The pulse duration. Remember the sound we had? So this is called the pulse duration. This is how long the pulse lasted. And you send the pulse out and you're waiting for it to what? Come back. It came back and it came back like this. একটা আসছে এরকম দেখতে, আর একটা আসছে এরকম দেখতে, a doctor who looks at this right away knows what the person is looking at. Turns out the fraction that comes back is always the same for different types of boundary out there. So তোমার যদি muscle থেকে muscle যায়, the reflection fraction বলা হয় is like 10% reflect করে. Fraction means you send 100, only 10 comes back, so 10%. So whenever you have a boundary, so if it goes from muscle to muscle, right, reflection is very minimal. If it goes from muscle to bone, the fraction of reflection is the highest. So when a doctor looks at the structure, they know right away which is the bone. Yeah, the last one. So this came from the bone. Now we know the what taken for this pulse to come back. Time taken, right? Wouldn't I be then able to figure out how far it is? So amplitude scan use করে, you can precisely find the location of things inside your body. But let's say our second pulse এখানে আমি ছেড়ে দিলাম. Would that be a good idea? Remember the first pulse I sent? I send the second pulse here. Is that a good thing? No, because isn't now my incoming pulse and the reflected pulse overlapping each other? So where do you think would be a good place to put this pulse? Yeah, like somewhere here. So that সবকিছু ফেরত আসছে এখন. Now let's send it back again. Do you get my point? This whole thing that you see here is known as the pulse interval. Yes, exactly. Pulse interval. So pulse interval টা দুইভাবে দেওয়া হয়. একটা হচ্ছে অনেক সময় দেওয়া হয় in terms of time. Our pulse interval দেওয়া হয় in terms of frequency as well. How frequently you send it out, right? So yeah, this is how it looks like. এটাকে বলা হয় A scan. Why is this very important in medicine? So let's say a doctor wants to operate on a tumor or something in your eye. আচ্ছা চোখের মধ্যে এখন in your eye there's this place called the optic nerves. যেখান থেকে হচ্ছে information goes to your brain, right? আর তার চারপাশে there are a lot of rods and cones, retina, the place that captures the light, right? And operation করতে গিয়ে let's say there's some kind of problem, blood clot হয় মাঝে মাঝে, ওটাকে সরাতে হবে. যদি 1 millimeter left বা right যায় and goes into the optic nerve, right? Permanent blindness. Is you're poking the wire and circuitry that goes to your brain. এটা নষ্ট হয়ে যায়, right? Heal করা খুব difficult. So doctor যখন operate করে, how do they know exactly where to go? Do they like put the needle in and like scour around where this is? No, right? How do they know pinpoint bhave where the problem is? They do an A scan. The A scan tells you location to micrometer. The answer that you get is in micrometer range. So when they use machines, robotic arms use করা হয়, ওটা ওই exact pinpoint location এ গিয়ে just goes into the eye. So you don't need to worry about the left এ যাচ্ছে না right এ যাচ্ছে. Modern day তে যেটা আমি বলছি ওটা আগে হতো. They would actually try out যে কোথায় থাকতে পারে. So anyways, the thing is, this is how your ultrasonography works. Are you clear about this? Now let me show you something else. I know students will go like, I haven't seen this. If you have done ultrasonography, এটা তো দেখায় না. Do they show you like a bar chart and a graph on the screen? Not, right? What do you see? Yeah, you see actual like almost, I don't know how people actually figure out. I always see like a shadow, but the ultrasonographer can say like your, I don't know, liver is big, but I don't see a liver there. So the thing is, how do they know? So ওটা কি হয়, ওটা একটু ডিফারেন্ট. ওটাকে বলা হয় বি স্ক্যান. আমরা বি স্ক্যানটা করে আজকে শেষ করব. সো বি স্ক্যানটা কেমনে করে একটু দেখি. So B scan is exactly the same process that we did there, with one difference. It takes pictures every second, 25 of them, and it stacks the pictures up and then plays them. So it looks like a video, like real-time motion মনে হচ্ছে. So B scan-টা কেমনে কাজ করে? B scan-টা is the best for fetal scan. Like, if you want to scan a baby, because the distinction is very easy to make. I'll tell you why. So fetus prominent first feature is what? The skull. So skull-টাকে খুব clearly দেখা যায়. কেমনে কাজ করে আমি বলি. What they do is they send the waves out, like a barrage of ultrasound if I send for it. And as the ultrasound goes through the body hasn't formed yet that much, right? These parts, they're going from the amniotic fluid. There's this fluid where the baby is, right? ওইখান থেকে it's going to the skull. The difference in density is insane. It's from water to solid crystal minerals, right? So যেটা হয় এখান থেকে রিফ্লেকশনটা অনেক স্ট্রং হয়, and যে রিফ্লেকশন গুলো ব্যাক করতেছে they're very high intensity. কেন? Because the boundary is very strong. The computer then takes this information and does this. যেটা করে যে জায়গার ইন্টেন্সিটি গুলো very large, ওই জায়গাগুলোতে it gives a color. এটা আর্টিফিশিয়াল একটা জিনিস দেখো তোমরা. ওরা কি করে, যে জায়গাগুলোতে রিফ্লেকশন বেশি হয় ওই জায়গাগুলোকে স্ক্রিনে কেমনে দেখায় as a bright spot. And that's the boundary that you see eventually. And that's why the ultrasonography that you do looks like a shadow, because you're basically seeing the what parts of the body, the contrasts in parts of the body. And that's why they were skullta সবচেয়ে easily figure out করা যায়. কেন? Because the skull is very dense, right? So organs that are different material, like liver, kidney, right? Egular ultrasonography করতে বলে. কেন? Because these are completely different material. They will give you a completely different picture because of the boundary. এটাকে বলা হয় কি scan? And the B stands for brightness. Brightness scan বলে, আর এটাকে A scan বলা হয়. This stands for amplitude scan. Okay. Right, so this is the basic process. We have the map left So math আমরা next ক্লাসে করবো, okay? কম্পিউটার গ্রাফিক প্রসেসিং করে পরে আগে এটা সম্ভব হতো না, তো আগে জাস্ট এই স্ক্যানিং হতো।
Recording stopped.
কবে লাস্ট ক্লাসে? See that box there? ওই বক্সে আছে। টিপিক্যালি তোমাদের ক্লাসের পরে হচ্ছে যদি থাকে আউট সি ইট বিকজ একটা গ্যাপ থাকে, তো আমি দেখিনি কোনো সময়। আর there's this one calculator here. Is this yours?
এম লেখা আছে স্যার, এটা একদম এই জায়গাটা এম লেখা আছে।
এই 3 এর উপরে নাই।
তিনটা কোচিং খুঁজে পেতে কোথাও নেই।
এমটা ক্যালকুলেটর হচ্ছে আজকাল খুবই হারায়
হারায় গেছে।
and then never comes back. I have seen students calculator পড়ে আছে নিয়ে চলে গেছে।